Hello and welcome to Earthquake Tip number 22. My name is Shailesh Kumar Agarwal, Executive Director of BMTPC, and I'm going to present to you all about earthquakes, its concepts, terminologies, and how to construct buildings and structures to withstand earthquake forces through 32 earthquake tips, which are authored by Professor C.V.R. Murthy, mentored by Professor Sudhir Kumar Jain, and developed by IIT Kanpur in association with Building Materials and Technology Promotion Council, that is BMTPC. Through these tips, our aim is to spread right technical information in simple to comprehend language to our professionals who are in the field designing and constructing structures, especially our architects and engineers. But before we start, let's make a pledge that any new structure we design or build must be earthquake resistant. This earthquake tip number 22 will explain you why are short columns more damage during earthquakes. In order to explain the tip, let's first understand which columns are short. During past earthquakes, RCC framed buildings that have columns of different heights within one story suffered more damage in the shorter columns as compared to taller columns in the same story. As you can see in this figure, there are two examples given of buildings with short columns. First is building on sloping ground, as you see in figure 1A, and building with mezzanine floor, you see figure 1B. Poor behavior of short column is due to the fact that in an earthquake, a tall column and a short column of same cross section move horizontally by the same amount, let's say delta, as shown in this figure 2. However, the short column being stiffer as compared to the tall column attracts large earthquake forces. Let's define stiffness again. Stiffness of column means resistance to deformation. That is, larger the stiffness, larger is the force required to deform it. If a short column is not adequately designed for such a large force, it can suffer significant damage during an earthquake. This behavior is called short column effect, and the damage is often in form of diagonal cross-shaped shear failure, which is brittle in nature. And this was also explained to you in earlier tip. Now let's understand the behavior of short column by looking at this figure 1 again. Many situations with short column effect arise in buildings. When a building is rested on sloping ground, as shown in this figure 1A, during earthquake shaking, all columns move horizontally by the same amount along with the floor slab at a particular level. Remember, rigid floor diagram action as explained you in earlier tip. If short and tall column exist within the same story level, then the short columns attract several times larger earthquake forces and suffer more damage as compared to taller ones. Also, you can see in this figure 1B, the short column occurs in columns that support mezzanine floor or loft slabs that are added in between two regular floors. In addition to these two situations, there is another special situation in buildings when short column effect occur. Let me explain you through this figure 3. Consider a wall of partial height built to fit a window over the remaining height. The adjacent columns behave as short column due to presence of these half walls. In many cases, other columns in the same story are of regular height as there are no walls adjoining them. Again, as explained earlier, when this floor slab moves horizontally during an earthquake, the upper ends of these columns undergo the same displacement. However, the stiff walls restrict the horizontal movement of lower portion of a short column, and therefore the column deforms by the full amount over that short height adjacent to the window opening. On the other hand, regular columns deform over the full height. Let's understand this by this figure 4 again. Since the effective height over which the short column can freely bend is small, it offers more resistance to horizontal motion and thereby attracts a larger force as compared to regular columns. As a result, short column sustains more damage. It leads to typical diagonal cracking in a column adjacent to the wall of partial height as shown in this figure. How to avoid this short column effect and what is the solution? Let's understand that. In a new building, short columns should be avoided to the extent possible during architectural design itself. When it is not possible to avoid short columns, this effect must be addressed in structural design. The Ductile Drilling Code, that is IS 13920, stipulates spatial confining reinforcement to be provided over the full length of column that are likely to sustain short column effect. The spatial confining reinforcement, that means closely spaced closed ties, must extend beyond the short column into the columns vertically above and vertically below by a certain distance, as you can see in this figure. You see this figure? The right-hand column is a regular column having closed space, closed ties only at the ends, whereas the left-hand short column has spatial confining reinforcement throughout the height. As regards new buildings, it is okay, but in existing buildings with short columns, different retrofitting solutions can be employed to avoid damages in future earthquakes. Where walls of partial heights are present, the simplest solution is to close the openings by building a wall of full height, which will eliminate the short column effect. If this is not possible, short columns needs to be strengthened using established retrofitting techniques. Being a specialized job, the retrofit solution should be designed by the qualified structural engineer with requisite background. This is all about earthquake tip number 22. You can download this tip from www.bmtpc.org. The next earthquake tip, that is tip number 23, will be on why are buildings with shear walls preferred in seismic regions. Thank you.